Welcome! Let's take a look at finding the antiderivative of functions that are multiples of the function 1 over x. Notice our first example here is the antiderivative of 1 over x. Now, 1 over x can be misleading in terms of finding the antiderivative. It can be tempting to think of this as the antiderivative of x to the negative 1 power dx, and then try to, in essence, undo the power rule. Well, the power rule will produce functions of x to the n, where n is any integer, except when n is equal to negative 1. The power rule does not apply, or is not how you can produce a derivative of the form 1 over x. In fact, if we look down here in the corner, we see that the derivative of the natural log function does in fact produce 1 over x. And interestingly enough, if the argument to the natural log function is x, then the derivative is 1 over x. And if the argument to the natural log function is negative x, notice we would have a derivative that is 1 over negative x, and then by the chain rule, multiply that by negative 1. So both the function natural log of x and natural log of negative x, they have the same derivative. So because the natural log function, whether we have a positive an x or a negative x as an argument, has the same derivative, when we integrate our 1 over x, the antiderivative is the natural log of the absolute value of x plus c. We do this so that we have a unique antiderivative. And because it's not clear whether an original function could have been the natural log of x or the natural log of the opposite of x, this agreement allows us to have a unique antiderivative. So when we see the antiderivative of 1 over x dx, that is going to be the natural log of the absolute value of x plus c. And then if I take the derivative of the natural log of the absolute value of x, I will in fact get 1 over x. So let's just confirm that. So the absolute value function, absolute value of x, is defined as x if x is not negative. That is, if x is positive or equal to 0, when we take the absolute value of that number, we keep the value of that number. However, when our value of x is negative, then we change the sign of the number. So absolute value of x is also opposite of x when x is negative. So now let's use that idea with our natural log function. So we have the natural log of the absolute value of x. Now note that the natural log function is not defined at x equals 0. So when we use this definition for absolute value of x, we will be neglecting the case where x is equal to 0. So the natural log of x is equal to the natural log of the absolute value of x is equal to the natural log of x if x is positive. And if x is negative, then the natural log of absolute value of x will be the natural log of the opposite of that negative number, or the opposite of x. Now, let's go ahead and take the derivative of each of these. So for when x is positive, we're taking the derivative of the natural log of x. which is 1 over x. When x is negative, we're taking the derivative of the natural log of the opposite of x, which is 1 over the opposite of x, times, now we have to multiply by the derivative of the argument. Derivative of negative x is negative 1, which ends up giving us 1 over x. So you see that the natural log of the absolute value of x actually has the derivative being 1 over x. So therefore, the antiderivative of 1 over x must be the natural log of absolute value of x plus c. Let's look at our second example here. We have the antiderivative of negative 5 over x. Well, negative 5 over x is the same as negative 5 times 1 over x. So let's factor out our constant negative 5. And so we have negative 5 times the antiderivative of 1 over x dx. And we now know that the antiderivative of 1 over x dx is the natural log of the absolute value of x plus c. I hope you find this helpful.